Science Uncut, presented by the Volkswagen Foundation.
When it comes to big data, we tend to think of astrophysics, medicine, or economics rather than history, literature, or the arts. In his talk, Andrew Prescott explains why this is a mistake. Datasets in the humanities have come to rival those of scientists. The Shoah Foundation's documentation of the testimonials of Holocaust survivors, for example, is twice as big as the Sloan Digital Sky Survey. Library catalogs or family history services like Ancestry.com now handle datasets in the petabyte range. 1 petabyte is 1 million megabytes. The sheer amount of data now available in the humanities forces us to come up with new ways of handling it. Reading through historical records, for example, has become impossible. Just take the electronic records of George W. Bush's second presidency. They include 200 million emails. No historian could read them all. Andrew Prescott describes the many approaches to dealing with big data in the humanities. One is to look back in history and find out how larger than usual amounts of data used to be handled. Text data in ancient Rome, for example, or census data in 12th century Britain. We also need to reflect about the role and meaning of correlation and causality and the way data are contextualized. Data are never raw and never objective, Prescott argues. We therefore need critical data studies, and we have to come up with new ways of representing information. Andrew Prescott is Professor of Digital Humanities at the School of Critical Studies at the University of Glasgow. He gave his talk on March 25, 2015, in Hanover at the Herrenhausen conference, Big Data in a Transdisciplinary Perspective. The conference was organized by the Volkswagen Foundation. The title of Prescott's talk is Big Data in the Arts and in the Humanities.
I certainly feel on this occasion slightly nervous in that I really am addressing an audience who probably have far more experience and far more knowledge of the issues than I do. And I'm conscious that I came to these issues by virtue of being somebody who started out working with medieval administrative records and became deeply interested in the way in which they functioned. And that led me into an interest in the structure of archives, the structure of medieval manuscripts, and from that into an exploration of really the way in which the cultural record worked. And that inevitably took me into an engagement with digitization pretty well as soon as the World Wide Web appeared, and one could immediately feel that this was something that was going to change everything in the way in which we engaged with our cultural record. And I see the issues that we've already heard about, the issues around data, the issue around sizes of data, as an extension of that, and feel that some of those historical perspectives are ones that are very helpful to us in dealing with a very rapidly changing situation. I cut my digital teeth working on a project to produce a digital facsimile of the Beowulf manuscript, the famous first great literary masterpiece in the English language in the British Library. And at that time, techniques were still very experimental. This was in 1993, 1994. We were using medical imaging cameras, and these were producing what seemed to us the absolutely crazy file size at that time of 21 megabytes, which was regularly bringing the British Library network down. We would get a phone call from the network administrator saying, "What are you doing?" But now I turn to this example, and I was very struck by Christine's earlier example of the Pisa Griffin, and how when one's working at a very microscopic level, one rapidly gets into a position where microscopic images are producing vast data sizes. This is an animation of neuron activity in the brain of the embryo of a zebrafish. A zebrafish being transparent is very good for this type of imaging. The neurons have been genetically engineered so that you could see their movement. Sorry, it's just reached the end of the clip, but you could see what was going on there. That was the first time that the movement of neurons in the brain of a vertebrate animal had been imaged. So it's groundbreaking images. But that very, very short animation sequence of the movement of neurons in a tiny fish larva was a 1 terabyte image size. It's a vast image size, and comparing it with my 21 megabytes for a image of a manuscript, 1 terabyte image is truly a world where we find it very difficult to deal with that scale of data. We've already heard a number of examples of very large data resources from scientific experiments, most famously, of course, the Large Hadron Collider, but also one thinks of the Square Kilometre Array, which in its first phase will generate in excess of 1 exabyte of data each day, more than the current global internet traffic, which will eventually rise to 10 times the present level of global internet traffic. In fact, I think we could say that the Square Kilometre Array, unlike Kim Kardashian, really does have the potential of breaking the internet. At this level of scale, and these are likely to be by far in the immediate future the largest data sets that we're dealing with, it might seem that this really has very little to do with the arts and humanities. One might feel, despite the Pisa Griffin, that we simply aren't in the arts and humanities going to produce data sets of this size. And certainly that is unlikely at this scale in the future. But what I'd like to suggest in the first instance is that there are increasing numbers of humanities data sets which are rivaling scientific data in their size. Arts and humanities researchers frequently use sound and video recordings, and any collection of time-based media quickly grows to a very large size. We've already heard about the Sloan Digital Sky Survey, but the Shoah Holocaust Survivors Testimonial Collection at 20 terabytes in size is about twice the size of the Sloan Digital Sky Survey. One of the most important cultural resources for arts and humanities researchers in the UK, of course, is the BBC, and the digital assets of the BBC were recently estimated to already be about 52 petabytes of data. Well, of course, these video and sound collections comprise unstructured data, but collections of structured data, particularly of the sort often used by historians and literary scholars, are rapidly moving towards the exabyte scale. The US National Archives is expected to acquire over 350 petabytes of electronic records over the next 8 years, while the web archives being created currently by national libraries are already running to the multi-petabyte scale. One of the most popular and lucrative activities on the internet is family history, and family history services already hold billions of digital objects. The family history service Ancestry.com held in August 2014 14 billion digital objects, and it's adding 2 million digital objects to that a day. There's a new data centre being built in Scotland by the corporation that owns the Find My Past service, which will have 500 petabytes of storage. Similarly, linguistic corpora have for years been among the largest data sets used in the humanities, with carefully curated corpora such as the Corpus of American Contemporary English containing 450 million words. But even these are now being dwarfed by the new web-based corpora, such as the Wikipedia corpus, and by the Ngrams corpuses from Google Books. So these issues of scale are increasingly start to affect the humanities. And that's really part of a growth in the scale of material with which humanities scholars have dealt, which has increased over the past 100 years. A very good way of looking at that is by looking at collections of correspondence and papers, which are a staple of humanities research. The papers of the celebrated Victorian Prime Minister Gladstone in the British Library comprise 160,000 documents in 762 volumes. And that's at a scale where if you had a long-term research project, you could seriously contemplate reading all these papers. Then if you turn to the size of the archive from Margaret Thatcher's premiership, you've got about 1 million documents. So that immediately forces you, if nothing else, to be much more specialist in the way in which you're approaching, much more selective in the way in which you're approaching the archive. And of course, the arrival of email accelerated this process. So with the collapse of the Enron Corporation, you're looking at about 150 employees generating almost half as many messages as we get from the papers of Margaret Thatcher's premiership. So already by the point of the Enron Corporation, in thinking about email, one's beginning to start to think that simple data mining techniques are going to be essential for historians using this material. But it's probably not yet on a scale that required you to completely reconsider your research methods. And for Gladstone, Thatcher, and to some extent Enron, you could argue that traditional research methods hold good. But if we look at the presidential papers of George W. Bush, there's a sea change. The electronic records from the Executive Office of Bush during his second presidency comprise over 200 million email messages, over 3 million photographs, and over 30 million other electronic records. Well, my inbox is bad enough, but I've never had 200 million messages awaiting for reply. To deal with this quantity of information, traditional approaches based around simple reading and not note-taking, even search, simply won't really work. And I think that's actually illustrated by the examples that are given by the George Bush Presidential Library of extracts from the archive, because they're carefully curated extracts that follow through the passage of a particular piece of legislation. Such as, for example, this email, which is part of a series of emails by Bush's senior advisor on education concerning the draft of a piece of educational legislation during 2001. So you can get a kind of a limited traditional view of the progress of that legislation from these emails, but you immediately notice the potential of the metadata associated with this email, which actually, of course, overwhelms the message. And can immediately imagine that a historian wanting to look at the way in which the office politics of the White House during Bush's presidency worked out might want to try and explore the way in which those copying and to fields in emails could be analysed. There's a lot of potential there. But as soon as a historian starts thinking about wanting to analyse that, really to look at things on the scale of 200 million emails, you're going to have to start to rethink the method by which you approach it. And you're probably going to have to look at something like this. We would have to look at visualization, and this is a sample visualization of the frequency and relationship of different words and terms used in what were called significant action reports in the WikiLeaks material describing military incidents in Iraq. In order to cope with a large amount of material and the interrelationship of a large amount of material in a corpus like the Bush emails or WikiLeaks, we really quickly get to a point where we have to start thinking about visual methods of analysis like this, which for historians and other humanities scholars potentially represents a big shift in method. To my mind, one of the most convincing definitions of big data is that provided by Adam Jacobs, which doesn't try to describe big data in terms of a particular number of bytes, but rather describes big data in relativistic terms, as data whose size forces us to look beyond the tried and true methods that are prevalent at that time. Large data sets such as the Bush Email Archive and WikiLeaks are obliging humanities researchers to develop new working methods which are not only more quantitative but are more visual, haptic and experimental. And these are the first very tentative explorations of arts and humanities in the world of big data. These responses to big data aren't only coming from humanities researchers concerned to categorize, classify, and explore information. Some of the most interesting reflections on big data are coming from artists, such as my former colleague at King's College London, Michael Takeo Magruder, who uses WikiLeaks in this compelling work called Insurance AES 256. To reflect on the nature of the media landscape post-WikiLeaks, and particularly on one mysterious document in this leaked material. So, big data, I'd suggest, is here for humanities researchers and in the arts, and we're starting to think more and more about it and to feed into the sort of discussions that we've already heard this afternoon. So, not surprisingly, big data has begun to attract much attention from research funding bodies in recent years, and we've had major initiatives here in Germany with the establishment of the Berlin Big Data Center and a Competence Center for Scalable Data Services. And many other European research councils have recognised the growing importance of big data in the arts and humanities, with the Netherlands Research Council, for example, funding projects using big data techniques in the study of subjects such as reference cultures and the development of cultural elites. In the UK, we were particularly pleased that part of a government grant in 2014 for research across disciplines into big data was earmarked specifically for research into the arts and humanities. And this enabled the establishment of a wide-ranging portfolio of arts and humanities big data projects funded by the UK's Arts and Humanities Research Council, or AHRC for short, and these AHRC projects are just reaching fruition. Now, obviously, I can't here hope to give you a detailed account of all the projects, but I just want to give you a sense of the wide range of methods that they all explored. A surprisingly good example of big data is legislation. There are an estimated 50 million words in the English statute book, and 100,000 of those words are changed or added every month. In fact, we recently had a piece of legislation relating to our second, we get on these things very slowly sometimes in Britain, our second high-speed railway link. And the piece of legislation was so lengthy that it was impossible to read it between the time of its publication and the time it was discussed in Parliament. And that's a very good example of the issues of big data. And the AHRC Big Data for Law project is using big data techniques to improve access to legislation and try and make this sort of material more manageable. There are other big, large textual corpora which are key for arts and humanities researchers. Another important one is the history of medicine, and the National Centre for Data Mining in the UK has been working on data mining corpora for the history of medicine. So that's one aspect of what we've been doing, that's working with textual corpora. Another key technique, I think, for humanities researchers is the linking of data sets. For example, at King's College London, a series of projects over the years looking at the prosopography of early medieval Europe and the Byzantine Empire have actually gathered information on most of the recorded population of early medieval Europe. But it's all in separate projects, in separate data sets. So the Snapdragon project is looking at methods and issues in linking those prosopographical data sets together. In music, again, a lot of information is in separate bibliographical data sets, which in themselves are very large in scale, but which we've always interrogated separately. And again, the big data history of music is exploring methods of linking those together. As I've already indicated, for arts and humanities researchers, unstructured data is very important. So a series of projects have looked at issues around film, images and music. For example, the Deep Film project at the University of Sussex and the University of Brighton has looked at methods of improving the annotation of issues and incorporation of issues about production within film. Another project at Lancaster University has been looking at improving techniques of optical music recognition, while the Lost Visions project in Cardiff has been looking at the retrieval of literary illustrations, which are otherwise undocumented from 19th century periodicals. Linked to that, of course, is a strong interest in visualization, and other projects have explored visualization of humanities material, such as links between a distant reading of crime fiction, or have looked at the way visualization works, as in the Seeing Data project, which has educational resources about using visualizations. And there have also been important contributions in the critical study of data, whether through a project called Our Data Ourselves, which is looking at the types of data that we ourselves are generating from smartphones in particular, or another very nice project at Sheffield, which looked at the way in which a single temperature reading from a weather station in Sheffield went in different directions, ranging from Met offices through to the financial markets. So it's a really quite wide-ranging portfolio of activities that the AHRC has undertaken, which also works into spatial areas with a project looking at deep mapping, the literary history of Edinburgh, and also looking at material cultures through archaeological 3D imaging, or a project we'll hear more about later on called Tangible Memories, that's looking at Internet of Things technologies in the home. Within this basket of projects and these loose techniques that various techniques that I've loosely described here, I think you get a sense of the types of methods that humanities researchers in particular have been very enthusiastic about within the sort of data domains that this conference is dealing with. And indeed, there's a series of workshops called the Big Humanities that draws together some of these, and maybe we should be able to start thinking about the big humanities. But you'll also get the sense it's a rather a mishmash of a basket, and I think that reflects something from some of the presentations we've heard this afternoon. It's quite a varied number of different techniques. And I suppose the immediate question looking at those is there anything that links them together methodologically? Can we see any overarching themes which are emerging from them that will help in our wider understanding of the emerging data landscape? And really, one does wonder, for example, with mapping, with linking, do they really represent anything very different to what we've done in the past? And that perhaps moves us on to a broader reflection on whether there really is, at the moment, a big data moment. Are things really changing that much? Or is it simply that we just simply now at a point where we have very large amounts of data that we can use, and for all the planning and discussion that we've had, in many cases, we're still not quite sure how we can best deploy data and expertise. And from that, one could wonder what distinctive contributions the arts and humanities can make to the kind of big data debates that are taking place here and elsewhere. So what I'd like to do really for the rest of this talk is to try and reflect on some of those issues and to see where the arts and humanities fits into that landscape. There are many historical precedents that could be seen as representing big data. For example, if we take that definition, the Jacobs definition of big data as an internet information problem whose scale requires us to develop new methods of working, then arguably big data has been a major factor in the development of human culture since antiquity. One of the reasons for the creation of the earlier systems of writing in antiquity was the need for governments to keep track of growing tax revenues. In my own period of the Middle Ages, many key documents reflected the need to develop new methods to keep track of increasingly complex administrative and social requirements. In England, the famous Survey of Land Holdings and Possessions, compiled at the order of William the Conqueror and recorded in Domesday Book in 1086, was a groundbreaking information processing achievement which collated, regularised and summarised information drawn from a variety of oral and written sources. The complexity and growing scale of government revenues in England led to the adoption during the 12th century of new mathematical and accounting techniques from Arab sources in southern Italy to create an elaborate system which we call pipe rolls and counter-based arithmetic based around the medieval Royal Exchequer in England. The medieval church also contributed to breakthroughs in the handling of information. The need for preachers more quickly to locate information in the Bible led to the compilation of the first verbal concordances to the Bible, which were pioneering experiments in the alphabetization of texts. So I think one contribution to the arts and humanities can make to our big data discussions is to provide a historical perspective. And that perspective might seem that big data has been with us for a very long time. However, there's no question that historical examples that could be seen as representing big data, such as Domesday Book or censuses of population, are descriptive and backward-looking. These information resources simply made it easier to retrieve information about property or people that was already known. I think, and there's something that we haven't really given much prominence to in our discussion so far today, that the aim of big data is fundamentally different. And one has to avoid hyperbole, but I would refer here, I think, to Victor Meyer-Schönberger and Kenneth Kulker's book on big data, which I think does vividly illustrate the importance of predictive analytics. And I think we need to put this into our discussions. And one of the most chilling quotes in Schönberger and Kulker's book is that of a director of a credit agency who bluntly declares that we know what you are going to do tomorrow. A more reflective view is provided by the director of process management at UPS, who states that prediction gave us knowledge, but after knowledge is something more, wisdom and clairvoyance. At some point in time, the system will be so smart it will predict problems and correct them before the user realizes that there's something wrong. I think another striking feature of the use of big data in a commercial context is the way in which it's claimed that extremely large quantities of messy data can produce better results than smaller and more precisely structured data sets. I think one will want to actually explore that more. Some of the discussion this afternoon has already explored it. But one, I think, has to take note of claims such as those reported by the inventors of the Google corpus, that it was superior to traditional linguistic corpuses because it wasn't annotated with carefully hand-corrected part-of-speech tags. But the fact that it's 1 million times larger than the traditional corpuses outweighs those drawbacks. A further nature of the use of predictive analytics is the way in which we're told that it ignores causal relationships and focuses on correlations. So insurance companies who've established that lifestyle factors predict the likelihood of taking prescribed medicines weren't interested in the reasons for this, but only in the accuracy of the prediction. So certainly from my perspective, I think the thing that catches my eye is the claim of predictive analytics. And I think we need to factor this into our discussions. A problem for us, thinking about it from a scholarly and research point of view, is that the claims of predictive analytics are mostly deployed in the retail and financial sector, so that it's actually very difficult for us to get a handle on how we can use it more benignly in research terms, and indeed what the issues are in using it. I think we need more research into the methodological robustness of these techniques. I think that's an urgent area. Very good illustration of that is Google Flu Trends, which was originally cited as very much a leading example, but then shown to not be so robust as was previously thought. The use of nowcasting methods is supposedly correcting that and producing a more robust result, but the whole matter is still, to a large extent, mysterious. And I think it really does require further discussion and further investigation. As predictive analytics is moving out of the retail and financial sectors and starting to be deployed more in a public sector situation, particularly as was mentioned earlier, through the use of open data in British and American cities, particularly in the United States, I think it's coming more into plain sight, and we can start to think about the ways in which we relate to it. For example, to give some examples from the United States, in Chicago, we heard at a conference recently about a system where indicators have been identified which will predict where rodent infestations will occur in the city, so that the city government can take action for preventative measures. In New York, predictive analytics have identified hotspots for unlicensed building conversions so that the work of inspectors can be more effectively targeted. One of the most controversial and I think interesting areas from an ethical point of view is, of course, predictive policing techniques, which work out the likelihood of individuals committing crimes. In Chicago has been taken as far as the issue of warning notices and preventative measures from the police. Now, again, it might seem that this has very little to do with the arts and humanities, but it's interesting that in Britain, our portfolio of AHRC projects included a project which explored how far online betting might be more effective than polling in predicting election results. And similarly, it's one of the aims of the Big Data for Law project that I described, is to use predictive techniques to analyse the structure of legislation and suggest how legislation might be improved. Another example, not in the portfolio I mentioned, of an AHRC project that's interested in the use of analytics of that sort is one that's looking to improve museum attendance. So these issues are starting to creep into the core areas of the arts and humanities. Film studies is a very core area for the arts and humanities, and services like thenumbers.com operate a bankability index that will provide you with data enabling you to work out who will be the most effective members of cast, members of crew, directors to use on your film. There are also, sorry, I've managed to lose the edge of the text there. There are also projects, services which offer to optimize film scripts using data analytic techniques in order to work out whether film scripts will be commercially successful. And it's really intriguing to note that academic publishers, John Wiley, have recently signed up to the IBM product, Pure Data Analytics, and have expressed an interest in whether they could use analytics of this sort to optimize decisions about accepting academic books and journals for publication. So I think there's some real challenges here, and I think that they are challenges that are really quite fundamental to the arts and humanities. There's been a lot of discussion about the role of quantification and scientific method in the arts and humanities, but that's been rumbling on for 40 years and is to some extent a long-standing discussion, and we have a lot of experience dating back to the ideas of cliometrics and the new archaeology in the 1960s about the role of quantification. So big data, again, that's not a new challenge or a new tension. I think where it's new from the arts and humanities is in a number of areas, and these are very fundamental to the way our methodologies in the arts and humanities, and we need to actually address some of these issues. Because I think they challenge assumptions about the way in which we're using information in research. The distinguished historian and literary scholar, historian Tim Hitchcock, and the literary scholar Jerome McGann recently argued that a distinguishing feature of humanities scholarship was precision in the curation of primary materials and in the presentation of primary materials. But we're being told that maybe messy data isn't such a problem if you've got sufficient computing power to deal with it. That's a big challenge. There are questions about existing research methods. Data-driven research sounds something that's actually very opposed to many of the primary research methodologies within the arts and humanities, partly because it raises questions about causality and about human agency, which are very key to the way in which we've constructed mental frameworks for the arts and humanities. I think a big issue, again, which I would stress, is that when one's looking at predictive analytics in particular, the way in which retail and finance have really driven that forward, again, makes it very difficult to work out how we fit it into a scholarly context. And all that really amounts to a challenge to the theoretical frameworks that have been elaborated in the arts and humanities over the past 50 years or so. So I just want briefly to indicate some of the ways, with reference to our projects, that I think in which we can address some of those challenges. I think the first and most important thing that we can bring to the table from the arts and humanities is in addressing that area of developing new theoretical frameworks and thinking in particular about critical data studies. And I think it's a critical approach to data that's very key. These can embrace also ways in which we think about causality and messiness of data. And there's a lot there that we can draw on. I think we should explore the spaces and the flow of big data more. Data, I think, depends differently in different ways in which it's used, as Christine was emphasising earlier, and we need to explore how that's happening much more on the ground. And actually to kind of think about, in looking at how that's happening, the sorts of moral values that humanities scholars have promoted in literary, historical and other contexts, how we promote those in the data world. Design has a role there, as indeed does the way in which we contextualize big data. So in the end, if you wanted me to sum up what agenda I think we can bring to bear from the arts and humanities on this, it amounts to the humanization of big data. We've already heard about Chris Anderson's notorious article on the end of theory, and the aftershocks of that, although, as Christine mentioned, it was swiftly debunked, the aftershocks of that still reverberate. There was a very interesting article on digital humanities in the New York Times in 2010 that seemed to echo what Anderson was saying, and saying that humanities scholars should forget about political and philosophical isms, forget about those isms, and start focusing on data. Data is the next big thing. I think amongst the various very interesting articles which were opposed to Anderson's comment and which have really reacted against his very positivist claim to a return to a very positivistic approach to materials, was an article by Calibert looking at it from the point of view of biological sciences and saying, illustrating how Anderson's claims broke down in that particular scientific context. And it had a wonderful quote from Charles Darwin, which seemed to me to say everything that you needed to know. All observation must be for or against some view if it's to be of any service. So in that kind of reverberation from the Anderson controversy, it's been very interesting to note how a number of commentators have really emphasized how data of various sorts is a cultural construct, has strong cultural and social connections, how it's often situated, contingent, and incomplete. Bowker had this wonderful early quote that raw data is an oxymoron on a bad idea. My colleague, the archaeologist Jeremy Huggett, has again recently emphasized how data is theory-laden. I think that's a very important concept. And very similar words were used by Kitchen and Lariat in a recent article about data being situated, contingent, relational, and framed. What does all that mean? It means that all data is deceptive, it's ideological, it's culturally constructed. Think about the example of a library catalogue. You would have thought a library catalogue would be almost about as objective an object as one could imagine of data. But how do you select which items of information about books you give priority to? That's a cultural reaction. And then the people who appear in the catalogue, how do you decide to define them? If you, for example, are defining royalty or nobles, often there's an enormous amount of social and political baggage you bring to bear simply by giving them titles. If you start to include women, do you include a married woman under her husband's name, as we used to in the British Library, almost as a subset of her husband? That's a cultural discussion. In fact, it used to amuse me that if you understood the typographical methods of the printed British Museum catalogue, it had never recognised the independence of the United States of America because countries were given typographical hierarchies. And again, that's a cultural construct. So library catalogues are cultural objects and they're theory-laden. And we could take that further into the world of big data. I'm very interested in autobiographies of working men at the time of the Industrial Revolution. And I recently did an exercise looking to see how far they were on Google Books. I thought most of them would be, and to my surprise, found that most of them weren't. The reason's a very simple one, is that the working men who were very successful, who made a name for themselves, tended to find commercial publishers. And they went into the big, famous libraries, which is what Google have digitized first. Google doesn't seem to have taken any interest to date in local libraries, in regional libraries, where precisely that sort of information in printed editions, which were quite short, is to be found. It's not there. So Google Books, though claiming to be digitizing everything, actually is hardwiring into the digital record a very, very strong, almost a rather Silicon Valley view of where knowledge is and what knowledge is to be important. So that's the sort of thing I think we can very helpfully explore. And I take as a manifesto for that an article by the geographers Dalton and Thatcher, which appeared last year, which called for the establishment of critical data studies. And I think the 7 points here really speak for themselves, but I draw your attention particularly to numbers 1 and number 4, situating data regimes in time and space. That's absolutely critical. The time position in which we produce data, the space position in which we produce data, fundamentally affects it. And just as I've been attempting to do, illustrate the ways in which data is never raw and never objective. That's, to my mind, fundamental to the scholarly methods of the arts and humanities, I think it's got to be at the heart of our response to the challenges of predictive analytics and to big data. And I think it's nicely illustrated in one of our projects in the AHRC, The Secret Life of a Weather Datum, which, as I said earlier, takes one single temperature reading and through this tube map explores the use that's made of it. And what's interesting in exploring the journey of that single temperature reading is the way in which it moves from open collaborative spaces at a local level into spaces, when it gets to the Met Office, at a government and national level where its agency starts to be constrained and there are restrictions, right the way through to some of the most fascinating work that this project has done, has been interviewing people who use weather data in order to work the weather predictive market, or the weather market in financial markets, and the way in which the commercial aspects of the data are both controlled and created. So this is a very good example of what critical study of data could look like. Another example, I think, that is a different approach to critical data studies, but equally interesting in our portfolio of projects, is one in which Tobias Blenker, who some of you will know is the principal investigator, Our Data Ourselves, which is working with a group of 20 or 30 young coders called Young Rewired State in order to produce first an app called Mobile Miner that enables you to trace what's happening on your smartphone and what data you're providing, and then again to explore the spaces of the use of that big personal social data. So, pardon me, I quite pressed it. With that, I think we could actually kind of move on to more wide-ranging methodological considerations. And as I say, I think there's a lot of past experience that one can bring to bear on some of the methodological challenges that we're currently facing. I mean, the idea of data-driven research, I think, isn't necessarily as radical as it might seem at first sight, because humanities scholars have always had a complex interaction with primary materials. As I described earlier, my own research is very much driven by my engagement with the archives. So in that sense, it's very much data-driven, but we've never really formalised what that methodology involves. And I think there's some work that could be done there around those methodologies to produce a more sophisticated understanding of the methodologies. Likewise, we could look back to earlier schools, such as the Annales School of Historians, who were thinking about issues of causality and quantification in the 1930s in a very sophisticated way that seems to feed into some of our issues around data at the moment. It's in the nature of historical data that it's often quite messy and complex. And in thinking about messy and complex data sets, I think there's a lot that historians, classical scholars, archaeologists, literary scholars can bring to bear. And again, to illustrate that from the portfolio of projects that we've developed with the AHRC, I think this is very interesting. As I said, at King's College, a series of projects have pulled together much of the population of early medieval Europe. But how do we link that? That's what the Snapdragon Project's been looking at. And this is their first draft of an orthology that links that. And that's dealing with very fragmentary data sets. That sort of experience can really fit in. Of course, visualization is very important in all this. And I think I'm very pleased with the work the Seeing Data project has been done under the AHRC portfolio, because that is looking at helping arts and humanities scholars in particular to understand and better use visualizations. And this is another area I think where we can contribute. How you visualize and engage with data, I think, is another area the arts and humanities can really feed in. An exciting project under the AHRC theme is one by Ian Gwilt at Sheffield Hallam University, which prints out data visualizations and explores different types of hapticity around those visualizations. And within all that, design is very critical. We organised a conference last year in which there was this remarkable presentation from Stanford of work by an architecture student in enabling better design and representation of cancer cells. And I think that's a sort of transdisciplinary dialogue using design skills to approach large data about cancer much more effectively. There's an interesting cross-connection there. And I feel sure that our potential cross-connection with the arts can feed in very well there. I showed you an example of the work of Michael Magruder with big data earlier. Here's another very interesting project by him, which uses data mining to pull out images of flowers and then create these data flowers. And I think the use of data mining techniques by artists, again, is a fascinating crossover area where we can actually come to terms with some of the challenges of big data. Another artist I've worked with is Fabio Antinori, and he made for the Open Data Institute this project called Obelisk, in which continuous data mining occurs for references to crimes against humanity, and as they are found, the obelisk changes colour. So that's a very good example of the way in which different approaches to design, to art, can feed into our humanisation of big data. And as I say, I think that's very much the theme. I haven't got time to describe all these projects here, but you might find it, I put the slides up on SlideShare, you might find it interesting to explore them. They're all projects in which communities become engaged in telling stories around data. And I think it's that telling stories and adding meaning which is very critical in the process of humanisation of data. And to end what I think can be achieved, I'll skip over this quote because I know it won't work, and consequently that won't. But to show how that might be achieved, I'll end by referring to one project which I think is particularly interesting from that point of view within our AHRC portfolio. That's the project Tangible Memories. Tangible Memories is a project that uses Internet of Things technology in order to investigate how the care of the elderly, and particularly the care of elderly people affected with dementia, might be improved. And I think it's intriguing because if there's an area where one might feel that dehumanisation might occur, it might be the use of big data and indeed Internet of Things in the context of the care of elderly people. But what the Tangible Memories project has done is to work very closely with the old people themselves and to create, for example, objects. They take an object such as a biscuit tin and work out why that's important to the individual. They record their memories and that's then associated with the biscuit tin. In other projects, on-demand printing methods are used to enable elderly people to work up stories, their life stories, that they can share with their carers and with their family. So this project, this is an installation that shows the sort of old people's care facility of the future, which is actually very futuristic in some of the things it does, for example, with Oculus Rift, but in many respects looks reassuringly old-fashioned. And I think that combination of working with the community, of co-research, which has been a feature of our big data projects, together with the possibilities that are provided with big data, is a very good pointer towards the humanization of big data. And it's critical big data and humanized big data I suggest we should be looking for. Thank you very much.